that we're trying to work out. We're trying to solve, and we're trying to figure out what could be a possible value of x that makes this equation hold true. And there could very well be up to 3 possibilities. There could be none, but we're trying to get to the bottom of this. And in a weird way, we have to start by almost finding like a partial solution with our calculator, and we're going to employ a little bit of number theory, and basically we're trying to find a value that will factor evenly, will factor nicely into 588 or negative 588. So how I got there was the leading coefficient times the constant at the end. So the leading coefficient in this case, well, it's just the number 1. And the constant at the end is this negative 588. And one of the best ways to do this, other than just randomly putting in numbers in your calculator, is if your calculator has a table function, go to table and input this expression in for your function. And then when you get to start and end values, like your start and your end and your step, input negative 588 because that's the smallest possible value that could divide into negative 588, and then positive 588 because that's the largest possible value. And some other examples of this, let's say you were to do this with a different problem. You get like 20. Well, your start would be negative 20, and your end, or your largest, would be positive 20. So just something to note. And set your, too far. Set your step value to 1. From here, you'll get a table, right? Like a whole list of x's and y's, or x and f at x. And if you find one that outputs a 0, say in this case it's 4, you know that you found a factor. So in this case, that happens to be the factor. When you put 4 into this function, you get an output of 0. We're going to use this to kind of break down this polynomial even further. One thing I wanted to mention was using PhotoMath, or kind of looking at PhotoMath for these solutions. And PhotoMath describes it in a way where it instantly goes from this expression here all the way to this. And the reason why I was able to deduce this was by actually finding that factor. Notice this x cubed minus 4x squared. This has some relevancy. And yeah, it doesn't make a whole ton of sense. Like, one thing that could make sense from it is the fact that, you know, these two combine, negative 4 and positive 19, they combine to make 15, and then these two here combine to make 71. But then you're thinking, how do I know to split it up this way? And the answer to that is actually just doing long division. So I'm going to reset this problem, and we're going to take the approach of just using long division. And you know, the thing that kind of frustrated everyone in elementary school, like literally the hardest thing I think you have to do in terms of math in elementary school, is long division. And I don't know if it's still taught, but you don't really use it in everyday life, but you do use the skills that you get from it, like understanding or working with algorithms. Is like I don't know, I guess long division helps that part of thinking. Anyway, so this algorithm is taking this thing, this x, seeing how many times it fits inside of x cubed. We get an output, and then we take that output and we multiply it back through. Okay, well, let's go through a couple of these steps. X fits into x cubed, x squared amount of times. Multiply it back, we get x cubed minus 4x squared. Okay, So, well, that 4x squared showed up. And then we get if we were to subtract these, find the divisor, we get a positive 19x squared. That's where that's coming from. Okay, all right. Bring this down. Plus 71x. And then we do the exact same process. So this fits in positive 19x times. Multiply it out, we get the same thing. I'm going to start putting the positives. And then negative 4 times 19, I think that's minus 76x. And subtract these. And when we subtract negative, we're really adding, so we get positive 147x. How many times does x fit inside of that? Well, 147 times. And if we multiply this out, 147 times x, well, that's the same thing. And we got to bring this down. Minus 588. Negative 4 times 147, well, that's minus 588. So the same thing, we get a remainder of 0, so everything's good. This was a correct factor all along. Now the next step, well, first off, notice right here, all these numbers. We've got this 147, we've got this negative 76. They all fit together. But the next step here is actually to factor this stuff. And it's not easy. I would much rather, I'm going to find a good spot to put this. How about right here? Much rather just go right to the quadratic formula. So that's b, which in this case is 19, plus or minus the square root of b squared, which is 19 squared, minus 4 times a, which is 1, times c, which is 147. When we work this out in the calculator, we get something interesting. Oh, well, I guess it's all over 2a, but this evaluates to, if we just look at the determinant, so the determinant is everything under the square root, we get 361. Oh, why did I do that? 361 minus 588. And that makes a negative. So there's no real roots. And if there's no real roots, well, this is as far as we can go within the scope of this course. Now, maybe later on, you use complex analysis, which is just a fancy way of saying we can evaluate negative square roots. But for this course, this is all we've got. And the only solution to this, in this really messed up way, there's only one solution, which is, no, x doesn't equal 0. X equals 4. Yeah. All right, so hope this helps.